Okay, everyone. Our first speaker tonight is going to be talking about a topic that is very near and dear to my heart. That is React Native and Flutter. I myself have done native development for years, and I think React Native is awesome. I have not had the opportunity to dig into Flutter, but it's something that I think a lot of people come up to me at meetups and conferences. They ask and say, hey, what's the deal with Flutter? What do you think about it versus React Native? What about Dart and all this? Simon is here to talk to you about this. Simon worked at Facebook and he worked at YouTube in the past, so he is someone with a lot of experience doing mobile development or working at large-scale companies, and he runs his own consultancy. So he's out there in the trenches banging on all of these new tech stacks. So without further ado, take it away, Simon. Tell us about this awesome subject.
Hey guys, thanks for coming tonight. I'm gonna try to juggle a microphone, a clicker, and a beer, and we'll see how that goes. Okay, so thanks for coming. What I want to talk to you about today, and I know I'm talking to an audience of React Native developers about the struggles or the good and the bad of both React Native and of Flutter, but I think you guys will hopefully relate to what I'm saying, since we've kind of been on this framework and we know the good and the bad. So I'm Simon, like Harry said, I do training and consulting. And then I have a software agency as well, previously at Google and before that at Facebook. I don't know if we overlapped, but I think Harry used to be at Facebook too at one point in time. Let's see if my clicker is not always, thank you. Whoops. That way, yeah. Okay, cool. So as you may know, so Flutter is a little bit younger than React Native. So React Native is from Facebook and uses JavaScript and or your flavor of compiled to JavaScript language. Flutter uses Dart, which I think is like a really interesting difference there. Okay, cool. And so we're likely going to touch on some strengths and weaknesses of a framework that you love. And so it's worth mentioning that I really like both of these frameworks, and I've kind of made it a priority to be fair as possible. And so for the next 15 minutes, we're going to kind of dive into the strengths and weaknesses and kind of compare these frameworks. And hopefully we'll land on some concrete, like the key takeaway I want you to have from this is what the React Native, either community or the React Native, what we as developers can learn or can take away from looking at Flutter, which is the competitor in some ways, the strongest competitor out there right now to React Native. So, if you rewind with me back to 2015, sort of coming out of Facebook was this new hot thing that was kind of not so much write once, run everywhere, but more like, the mantra of the time was learn once, write everywhere, which was the key that they were trying to solve. And so the initial goal of basically bringing all the things that we love about React from web over to mobile, like a declarative approach to UI, one-way data flow, all the things you guys do every day, composition of components, of UI components. And so the key to this was that React Native was sort of the first kind of JavaScript-based cross-platform thing that was not a web view, was not HTML and CSS, right? It was native components, and that was fairly groundbreaking. And despite some rough patches, right, along the way, like navigation, like which we've been through like 7 iterations of, and with a lot of help from the open source community, we've effectively delivered on that original promise, right? Like learn once, write everywhere. Like you can be almost as good as native, but with the kind of speed and agility of writing in JavaScript. And this large ecosystem is formed around React Native, and you have lots of different choices when building. Different design patterns and state management, and even the language that you write in, right? So like if you want to write in JavaScript, great, or TypeScript, or Reason ML, or there's like any number of languages that compile to JavaScript, like hopefully not CoffeeScript, but you guys get the gist, right? Kotlin, I guess, technically can compile to JavaScript. So that's really powerful, and it imposes very little opinion on anything, right? Like it doesn't really dictate the way you do things besides the view layer. And this could be considered one of its weaknesses. So if we think about the sort of tech stack that we use today in 2019 with React Native, TypeScript is probably what you would use if you're starting out today. If you're on a legacy code base, it might be different. Expo which is like all of the things that should be in React Native Core but aren't. React Navigation, obviously, kind of all the modern React stuff. But let's flip over to Dart, and if I can get my slides right. And so, if we rewind again to 2015, where we were kind of when Facebook was releasing React Native, at this fairly obscure Dart conference, which I'm sure nobody in this room went to, and probably very few people were really into Dart in 2015. Google announced this project, or teased at this project codenamed Sky, and it was claiming that like Dart as a real, like take Dart seriously as a programming language. It is so fast, it compiles to native, and it can run 120 frames per second on Android, which is like really impressive on the Android devices of 2015, right? And so, it was kind of, people didn't know if it was vaporware or whatever it was, but because there was like nothing behind it except for a demo. But like 2 years later, it just sort of materialized, and it was announced, and we have this like, it was named Flutter, and it was sort of like, it came out the door with first-class support for both platforms, and really kind of delivered on a lot of the things that React Native maybe didn't have in the early days. So, for example, okay, cool. So it kind of came out of the door with like this like rapid development across both platforms, top-notch performance with this kind of like innovative GPU accelerated rendering, which is like the key, like the really key thing about the technology behind Flutter, right? Is that it kind of runs, if you think about like a game engine, how it just like renders pixels and like puts them straight to the GPU onto this kind of canvas. It doesn't like use the operating system's kind of like APIs to use the operating system's native components. It's really just use the operating system as like a blank canvas, right? That's maybe a poor description compared to how the Flutter guys would like to describe it, but that's kind of the gist of it, right? But it has all the modern stuff we would expect at that time, stateful hot reloading, and it came with like a robust set of tooling and stuff out of the box, UI components and everything, right? And so I think it was like really interesting that Flutter chose Dart as its programming language, which was a relatively obscure language at the time. But it's key to know that like internally, right, Google had been betting on Dart for years, and it wasn't winning on web, right? It was initially aimed at like, we're gonna replace JavaScript, and we're gonna ship a Dart VM with Chrome and everything. And that did not gain traction for whatever reason. But internally, like there was still like at Google a bunch of people who liked Dart. So, when choosing a language whenever they started this project, 2014, right, they were like, okay, Dart seems like a good candidate at that time. Which I think was maybe a unique decision, knowing now what we do about the landscape of languages. And we had this sort of second mover advantage. So everything every mistake that React Native made, Flutter could look at that and be like, okay, well, we're not going to make that mistake. We're going to come out strong and sort of like move quickly. Because if you remember React Native, they shipped iOS sort of mostly baked, 80% baked. Then 6 months later, they shipped like half-baked Android, right? And then like 2 years later, we kind of had all the pieces together to really develop on both platforms. But let's look briefly at what they both have in common. They're both open source, cross-platform, declarative approach to UI is pretty important because that's something that kind of React popularized, right? And especially the kind of component-based architecture. And strong performance characteristics compared to its predecessors. So if you think about React Native, came out with like really strong performance characteristics compared to what the cross-platform story was at the time, which is like HTML web view stuff, right? And it was like, hey, here's native stuff, it's really fast, we got this bridge thing. And similarly then, Flutter came out with really strong performance characteristics of its time too, right? Heavily invested by tech giants, not going anywhere anytime soon, kind of hopefully, right? Never know. Google tends to kill things at times, Facebook too, right? But I think more importantly than how they're similar, or more interestingly, we should look at sort of how they're different from each other, which is that we kind of want to look at these particular criteria, right? Like what's provided out of the box is a strong indicator, I think, of what is a core difference, right? The language, the styling engine, the layout and styling, type safety, things like that. So, and the ecosystem. And we'll touch on performance, but I don't think this talk is not a deep dive into performance. And the reason for that is because both frameworks are more than fast enough for what you're doing with them, right? I mean, if you're building a 3D game engine, that's like totally different. You don't use these kind of frameworks. But I think for business applications, for consumer applications, for the things that we're building, both frameworks tick all the boxes. They run perfectly well on new and old devices, and then you'll find some edge cases where you have to jump into native land. But I don't want to focus on like what is the performance on these kind of edge cases here. But I do want to talk about developer experience and ecosystem and community and libraries and things like that. So we'll start with Flutter. And so the one thing is like when you first jump into Flutter, it's actually a really fantastic experience. You jump in there, you have to learn this new language, but it's a really easy transition to make from a React Native developer, from a web developer. You get this out-of-box experience that is like incredible. Like it's incredibly complete, I should say, right? It gives you everything you need. You get these comprehensive widget libraries. You get theming that's like, from the first moment you start your project, it's like, what is the font face you want to use and the sizes and what is the colors? And like you set up a few settings and then just like the theme just magically kind of flows throughout your entire application. Navigation is like right out of the box. It's like, well documented, easy to use. And so like, frankly, like Flutter does kick React Native's ass in the out-of-box experience overall. And that was the very first thing you notice when you jump in there. It's it was well thought out and provides what you need. The authoring experience, right? Editor support. You get the considering like Dart is not a language that you're natively going to have support for in your editor, you can install this one plugin and just everything works, right? Your click to definition, your syntax highlighting, your autocomplete, everything. And it's an easy language to pick up. Like it's surprisingly easy. Like there's no crazy concepts that you've never heard of in there. It's, kind of standard OOP-ish stuff. And when you don't know what the API of something is, you just like go to source. Like you click through and you look at the actual Flutter source code and you can see, okay, these are the arguments this is expecting. And that was I found that very helpful. And stateful hot reload, it's kind of hard to explain without you actually experiencing it, but this stateful hot reload it blew my mind. Like I had not experienced that on something that felt so native prior to that. It doesn't feel like refreshing a web page at all. It feels like it just like, maybe similar to the Swift UI experience that is starting to be popularized right now, but it is totally worth experiencing. And so the rendering engine, the interesting thing is like, this is the selling point. This is the magic sauce that they have with Flutter, which is like this innovative high performance GPU pixel pipeline thing. Then, and like in doing so, they've recreated all of the native operating system components in both a Material UI flavor and in a iOS like Cupertino flavor. And it's all provided out of the box. But like the best thing is, you don't even notice. Like you just build your thing, you just be an application developer and you don't even know that there's this crazy rendering engine or GPU, whatever. Like it just works. And it bears repeating that like the widgets, the theming, the navigation, the scaffolding, the standard library, like if you remember in JavaScript land, the first time you had to try to figure out how to format a date, or the 100th time you had to figure out how to format a date, right? And you're like, do I pull in moment.js? Like, what do I do here? Do I manually like split some strings? Or, just do basic string manipulation? You don't have to think about that. Like it's provided in a real programming language out of the box. And these are some of the things we forget that we're lacking in JavaScript world, right? However, right, Dart. Like Dart is a struggle. After you get through okay, I can understand this. These are familiar concepts to me. It is a struggle to just like bury classes of like just like OOP inside of like instantiations, inside of inheritance, inside of like boilerplate. And so like a perfect example is like I want to add border radius to something. I can't just put like border radius 4, right? I have to like instantiate a box decoration class and instantiate a border radius class and then radius circular. And you just see this over and over and just like levels of nesting. And I get that there's like performance characteristics of not parsing a string at runtime or whatever, but you pay a penalty, right? You definitely pay this like verbose boilerplate cost. And it's, like it is what it is. If you're a Java developer, you're like, yeah, sure. I mean, like I have to write 7 lines of code to do this. Like I understand. And it even has some niceties that Java doesn't have, like named arguments. But if you come from this modern language like, Swift or Rust or something, and you're not like, don't expect to have this amazing language experience with Dart because it's not there. It is like the bare metal kind of OOP stuff. Like you can't just, in JavaScript, open a curly brace and just put some key value pairs in. Like there is no equivalent to that. You have to create a class, describe the private, properties on that class, and then use a constructor. If you come from TypeScript, it's like, yeah, that's tedious. It's a bit brittle, but it's not a deal breaker. But you might think to yourself, at least Dart has safe and a sound type system, right? And you would be wrong. You'd be wrong because they don't have null safety. I mean, it is a strongly typed language, and it will not let you assign a string to a number, but it does not have null safety, and this is kind of the thing that early Java suffered from, and you start to realize, like, why did it take us so many years in computer science to figure out that we need null safety? But for better or for worse, you can just say, here's a string called foo, and just not assign it, and it's like, sure, okay. Similarly, you can just like call an array out of bounds, and it's like, okay, well, I guess we'll just throw a runtime exception. And so, currently, I should say, Dart is not null safe. They're working on it. There is an effort that at least the issue is 1 year old that says, like, we're going to add this non-nullable by default stuff to the next version of Dart. So, there was a time when TypeScript, I guess, was not null safe also. So, take it as you take it with a grain of salt. And so, like, be prepared as a beginner. You'll jump in there, you'll forget to initialize some variables, and you will see null pointer exceptions. And they might sneak through to production, among other exceptions. And this really kind of gets me as a programmer, is that I call like a datetime.parser, I call a function, I don't know if it's going to throw or not. And so I may not find out until runtime that, like, when I give this a thing that the user inputted, that it throws, and then I'm like, okay, cool, I'll wrap it in a try catch, not the end of the world. But you don't always know ahead of time that I need to wrap this in a try catch, right? Now, like somebody who's been programming like Flutter and Dart for many, years might laugh at me and be like, that's such a new mistake. But this is the experience you get when you go into it. So just, layout system, right? So you saw a little bit of layout. It's a little bit verbose. It leads to a lot of nesting. So the way it works is you kind of like add a layer of nesting for everything you want. So you want to add padding, you kind of wrap it in a padding thing. You want to add border, you wrap it in a border thing. And you kind of wrap over and over, which has an interesting kind of side effect that you don't realize, which is that you can't easily abstract it out because it's built into the structure of the code. It's unlike just adding like CSS. You can abstract CSS out into another file, right? But overall, you get used to all of this stuff, and you ultimately pay a small, some would say it's a small price to pay for such a fantastic native level, fast, super hot reloading, like very nice to work in, and you can move quickly as a developer. So, that's the price you pay, right? So we'll kind of move over to React Native and kind of talk about its strengths and weaknesses, which you might be more familiar with these. So the, lets you move fast, building high quality UI. That's kind of the promise. All the things you already love from React on web. So your hooks, context, your render props, like these are things that like we take for granted, but they don't exist in other frameworks, right? Especially hooks, right? Flex layout, I think it's clean. You can like learn the rules of Flex in an afternoon and be productive with it, right? Okay. And TypeScript, I think, is an incredibly sort of ergonomic language with this incredible type inference. You could do a lot of things with safety. Like, you know what I mean? You can instantiate, you can pass really complex functions to functions and things like that. And if you do your types correctly, you won't shoot yourself in the foot and you won't have a runtime exception. Okay. So Expo, I probably don't have to sell you in this room on Expo because you guys are React Native developers. It is phenomenal. I don't think I've seen anything like Expo in other sort of development sort of tool chains. It's really hard to convey how much this impacts the developer experience, especially from getting going early on in projects, right? Sending an Expo link, to replicate a bug, you send an Expo link to somebody, they open it up, they can immediately have this reproducible thing, right? Especially with like Expo Snack, things like that. It supports web as a first-class citizen. That's pretty important. You get these build tools in the cloud, these over-the-air updates. So, font loading, asset optimization, things that really should be in React Native core, right? Like an icon, like that should ship with React Native. Like, let's be honest here. And so when we compare TypeScript with Dart, and I think this is a fair comparison because they're both fairly strongly typed languages that have little edge cases that aren't fully safe, yet have a dynamic kind of nature or meant to come from or be appealing to dynamic programmers, right? Because remember, Dart was originally poised to kind of replace JavaScript, and it turned out TypeScript won that battle, right? But you get things that you don't get with Dart, right? So explicit null safety is pretty important. We talked about that. But union types, you forget how important it is that you can just like, I can make a function that accepts a string or a number, right? And I can do things accordingly with safety. Or I can return string or null, right? Or I can return an object in curly braces with a status code and some data. You can't do that with, like you can't return A or B. You can't even return just a key value pair. Like there is a concept called like a hash map, obviously, but there are things that just feel natural for us to do in TypeScript that you can't do in Dart, including like just tuples. There's no tuples in Dart, right? Destructuring, things like that. So we use these every day, and for people who aren't familiar with these features, they're not missing anything. But if you use these and you go to a language that doesn't have them, you notice it, right? Language preference, whatever, it's usually biased based on the previous languages you've been exposed to. So if you've been using Haskell, you would probably think TypeScript is like awful because it doesn't have like whatever functional thing, right? So an interesting discretion thing here is that React Native, the rendering engine uses the built-in platform provided things, right? So if you open a calendar on Android, it's gonna use the operating system's date picker, right? If you use a calendar on iOS, it's gonna use that terrible scrolling wheel thing, you know what I'm talking about, for choosing a date. And like, for better or for worse, it uses what the platform provides. And that's good in many ways, right? So like you get this like action sheet in the bottom on iOS and you get something, modal thing in Android. However, like it does, like these things are similar in many cases, but slightly different, right? So like how does a particular view handle an overflow can be slightly different, and it can be a little bit frustrating, and we'll definitely get to that. So what are the but, right? Like these are all the amazing things about React Native that I probably don't have to sell you on, and like what is the but? Like where does React Native fall over and kind of Flutter shine, right? So the out-of-box experience is just, I wouldn't say it's terrible, it's just empty. You just don't get anything, right? You get like a handful of components that sort of work across, you get next to nothing. You don't get navigation, you don't get theming, you don't have any component library. If you literally render a text input onto the screen, it's invisible because it has no height and it has no border, right? So when I teach like beginners and stuff and they want to put something on the screen, they're like, where is it? Like it didn't work. I have to refresh again. And I'm like, no, it's there. Add a height and then add some like border, and you have to be able to see it. And you realize that there's just no widget library, right? So you don't even have an icon. There is literally no way to tell React Native, please use this font family across my entire application, on my buttons and my text inputs and my placeholders and my headings and my like alert dial. Like you can't. You have to roll your own theming library or find one on the web. And so you'll think to yourself, well, I'm really lucky that I live in a world where so many things exist on the web that are fantastic. And then you see NPM and you're like, NPM is a hot mess, right? It is just full of like other people's code that may or may not ever be maintained again. And you hope these two things work together, and everybody ends up with their own kind of cocktail of different UI components and state management paradigms and everything. And no two React projects are alike in the world, right? Give or take. And so internally at a company, you just standardize one and like whatever, right? But like in general, the out-of-box experience is like a little bit painful compared to Flutter because you just don't get much, right? And you just kind of like hope that the library author maintains it and that the next version of the library doesn't break backwards compatibility, which it might. And you have a package.lock file or whatever, a yarn.lock file to make sure that you don't break in a minor version, things like that you just don't have to worry about in the Flutter world. So you end up with this mix of packages, and that kind of whole thing that I just described is the fragmentation problem, right? And that's not the only problem, right? So you've got upgrading, like if you've ever upgraded React Native, historically has been really, really difficult. Flutter people don't think about that. They're just like, okay, I just like click a button, it just happens, right? And things don't break for whatever reason. Maybe it's just really internally well tested, or maybe the same people who write the upgrade are also writing the packages, but things generally don't break. We have this kind of issue in React Native world where it takes us 4 generations or 3+ generations to get anything right. We finally thought we nailed animations with animated, and it was built into core, and then it was like, well, actually, no, that doesn't really, let you do certain things. And then so was the one that came from Wix. It was like, it wasn't reanimated, it was interactable, and then we got reanimated, and then we got gesture handler. So we think we've nailed animation and gestures now, right? I think we've got it. I would have said 6 months ago that we nailed React navigation, but now the next version that's coming out, which is component-based and lets you use context finally got it right, I think. We'll see, right? But you couldn't use like current versions, current stable React navigation, you cannot pass anything with context and actually access it because you pass these complicated configurations and renders and things. So I'm sure you've struggled with that. I shouldn't have to describe that to you in too much detail, but I want you to get the big picture of this, like, you know, like all these little micro packages out there that are give or take solving some of our problems. And if you've ever had to figure out how to do keyboard handling, and you've used a keyboard avoiding view, and then you've had to been like, okay, do I configure it with padding or height, the one that needs to change? If you, I don't know if you guys have done that. Or you've tried to teach a beginner how to use alert in a way that works the same on both Android and iOS. It is literally impossible. Like, look at the docs and you'll realize how the first argument of alert is the same, it's a string, but all the other arguments are like how to display, which buttons to display, totally different across two different, like it's just nuts. And so we do have this, like, remember, it was never designed to be write once, run everywhere, and it shows, right? It's close, it's 94% of the way there. And so anyway, is that a small price to pay for the developer experience? Like, I think so, right? Like, we're gonna struggle with some incompatibilities, and in return, we get this like phenomenal framework that lets us use hooks, right? Kind of like to summarize everything we just talked about, like, what do we think, like, what's the takeaway besides just like pointing flaws at these two frameworks? Like, how can we look at that and be like, okay, what can we do, or like, what can we learn as the React Native development community, right? Assuming we don't have any core developers in this room, in which case we can tell you a lot of things. But as the community, right, we know what we want. We do want write once, run everywhere. We don't want to have to worry about things being slightly different on the two different platforms, right? There are times when you do want a very different look on the two platforms, but that's not really what I'm describing. I'm talking about when like behaviors are slightly different, particularly keyboard handling and stuff, right? We don't want to think about the platform. You know, if you think about web, right? We've been used to a platform on web where we can build things and they just run the same on Windows and Ubuntu and Mac or whatever, right? Like save a few small things like fonts. And so we don't want to wade through a dozen packages to find an image carousel, right? But currently we do, and we don't know which one to pick. So we just like ask our buddy, and he's like, "Well, I used one 6 months ago, and it was this one, and it kind of worked, right?" We don't want to wonder like, does this work with this version? I don't want to mess around with tsconfig or package.json or app.json or babel config and metro config and like all of the things that I have to do to kind of just get something out of the box. Now this is a solvable problem, right? And I don't want to have to think about like, is this package that I'm pulling in, does it have TypeScript definitions or not, right? Not to mention, if I do on TypeScript, on like Dart, if I press like command click to like go to definition, it's going to take me to the TypeScript definition file buried deep in node modules, and I don't actually get to see the source code, right? And then I have to like dig up some minified JavaScript thing, which is a struggle, right? And it's something that I think the community can learn from Flutter, and we're getting there. I think there will be a time when we all ship TypeScript alongside our NPM package or in such a way that we can actually view the source, right? In an ideal world, we would have officially sanctioned systems for types and testing and navigation and animation and internationalization, like as a pain point I haven't even touched on yet, right? Fonts, icons, theming, fetching, caching. I don't want to mess with this like keyboard behavior every time that I build an app, right? Every new project that I start, or image caching is like an issue. Font sizing, if you've ever like had something that looks great on an iPhone simulator and then you run it on an iPad and the font is tiny and stuff, it's like we don't want to like, and then you pull in React Native responsive sizing, right? Which is like some NPM package, and you're like, this is going to work great, right? And then you have to configure a bunch of stuff, and then it changes the way you do style sheets and things like that, right? Like this isn't a problem that we should have to think about as application developers. I don't want to think like, okay, I'll load my PNG from the disk, but now I wanted to load an SVG, but I can't. Like you can't just like load an SVG and display it. Like there's a lot of these small things that I don't think the core, I don't think these are on the radar of the core developers. So the community is finding ways to solve them. If you were on web and you had to write special logic to make the tab button move the focus from one form field to the next form field, you would probably think that the web platform is broken, right? You would expect the browser to figure these things out for you, but we overlook that we have to think about these in React Native world. We have to actually write like the keyboard has a next button, and that next button like moves the cursor forward. These are things that we have to do in React world that other frameworks don't have to think about in React Native world. So the good news is all of the things on the slide that we just talked about are like solvable today. We don't have to wait for core to implement we don't have to like invent something from scratch. Like internationalization and theming and fonts and icons, those are solved by other people. The difference is that each one is solved by somebody else. Like, theming is solved by Wix and like, widgets is solved by CallStack, and like all these different companies have solved the different pieces. So, and we end up gluing some things together, but it is solved. Like these are solvable stuff, right? I can make a layer of abstraction on top of forms to make that the cursor advances to the next form field. I can build a great UI kit, or I can use React Native Paper. I can curate and maintain a list of community libraries that are sanctioned for use at my company that I know will work with the version of React Native that is sanctioned at my company. And I can tell my developers, you don't have to think about which carousel to use for images, because we have one and we've already decided that it's good. And we've already done the research to see if it works with React Native gesture handler, right? Which is something that you probably want, right? But that's because we're filling in the gaps that React Native ecosystem or core has left. And that is something that I think we can try to sort of make de facto standards for, or push our companies to make a de facto standard for. Like the same way that React navigation has just become the standard for navigation, we need standards for internationalization and theming and whatever else, right? And that's kind of where we come in. Like that's where we as the community, we should try to kind of figure out like, okay, use another framework. This other framework nails a widget library. Like how can we learn from that? Like how can we build something, or how can we get our company to open source something that we use and promote it and maybe even get core to maintain it? Because what React Native really needs is a comprehensive standard set, like what Ruby on Rails did 12 years ago for the web development community, which is like, this is the way you do web development, and then people kind of learn from that, right? That would be nice if React could fill in that gap. And if you work on a large product team, you may not run into these problems as much, right? But if you work on smaller projects, or you work on projects more oftenly, then the responsibility is kind of on us, the developer, the community, to solve the gaps. And so, how am I looking on time? I guess we're good on time. This is basically the end. So please go out and try these other frameworks, and I think you'll learn a lot. And does anybody know what these two icons are? Speaking of frameworks. Yeah. All right, what do we got?
Swift icon and Android icon.
Okay, that is true. Okay, I heard Swift UI. Yes, so Swift UI, which I think is really revolutionary in that they took what we kind of learned from the community over the past 4 years, and then they just baked it into the platform, right? And I think that, and so this is the lesser known one that came out like 3 weeks before Swift UI, and nobody ever, because, Apple knows how to do product release and Google doesn't. So Google just buried it in Google I/O, but I think it's actually really noteworthy. So this is not just Jetpack. This is like Jetpack Compose is a declarative Kotlin framework that is currently released for Android and coming out soon on iOS as well. That is native compiled code, but that feels, or at least is intended to feel, like React Native. And hopefully it gives us all of the really cool stuff that we get out of Flutter, which ironically is also from Google. So, we'll have two things. We'll have two competing things from Google, which is probably a little bit unheard of. And that's it. That's all I have. So find me on Twitter and yell at me about my terrible opinions. And thank you very much for listening. I will say one plug, which is that I run a software consultancy. So if you guys need React Native development, we don't do as much Flutter. We have started doing a little bit of Flutter, but and then I also do React training through a couple of different organizations. And so yeah, hit me up on Twitter if you need anything at all, and come talk to me after this. And if we have a few minutes, I'll take a couple of questions. Thank you.
Hey, we do indeed have a couple of minutes, so we're just going to take two questions, and I'm going to hand this mic back to Simon.
Thank you.
Thanks. I developed a React Native app for fun a few months ago, and I thought it was very simple, couple of forms, few API calls, whatever. So I thought should be a day. It took me 3 days. A lot of that time was struggling to figure out whether I should use like React navigation or React native navigation, and whether which like component library to use. And so I'm curious to know, like, if these problems are solved, why is there somewhere that I can go, or a new developer can go and see, like, okay, these are the things you should do if you're starting a React Native project today?
I would love for that resource to exist, and if it does exist, like, I don't know about it, and probably every software agency has their own little cocktail of things that they use. I know we do, so at our agency, we just kind of pick a handful of things, and the UI kit that we really love is React Native Paper, because it's written in TypeScript, so it behaves well with TypeScript, and it's made by CallStack.io, which are like really good in the community of maintaining stuff. Navigation is React Navigation. So like, I know these things inherently in my brain. I don't know that anybody has articulated them somewhere, and if they did, I might not agree with those, so I'll make my own list, and then somebody else will make their own list. So, you know, how do we solve that? How do we put something out there that's like, this is your go-to place, right? And how do we even rate something, right? Do we say, okay, the one with the most stars on GitHub is the one I use, or the one with the most commits in the last 30 days? Like, I'm not sure how to, like, if there's a scoring system out there and the best way to do that. But I would love to be involved if people in the community are creating these kinds of curated lists of things that are maintained and useful and things like that.
Last question.
Yeah. Between the two platforms, like, how do you compare the SVG, you know, like how, because I was kind of disappointed with the last time I really used React Native. I was kind of disappointed with the SVG support.
Yeah, I wish that was baked into core, because you know that the operating system has it, right? It exists in native land, but we don't have access to it. So the last one that I saw was like parsing SVG in JavaScript land, and then rendering those as elements onto the screen. Because if you look for React Native SVG, it is it's almost like a DOM kind of for SVG, which is probably not what we're looking for. We want to display it like an image, right? So anyway, it exists. As far as I know, the currently common sanctioned way to do it is you use a Babel transform that transforms the SVG into React elements before at compile time, and then you just render those like you would import any other element. Yeah, it works out of the box. You just it's like displaying a PNG. I mean, like, that's the thing. That's what I'm getting at here, right? Like Flutter has solved these things in a way that makes sense. So, okay, that's what we got.
Well, could I get a round of applause for Simon, because that was awesome. Well, our next speaker tonight is someone who works at Coinbase. It's me. So I'm going to introduce myself. I am your host for the evening, Harry, and I am going to be talking about how the Coinbase Pro mobile app architecture. The Coinbase Pro mobile app is an app we just shipped, and I'm going to talk about how we went from nothing to an app within 6 months. Hopefully this janky clicker will work. Well, before I get into my talk, I'm going to give you some background information about me. So I'm the tech lead for the Pro Mobile project. I have been a mobile developer since 2010. Most of my career has been native iOS and Android development. I also ran my own consultancy briefly doing iOS, Android, and yes, React Native development. I was primarily a React Native developer since 2017, and I joined Coinbase late in 2018, originally working on the earn.com team. For those of you who don't know what Earn is, it's a service that allows you to perform tasks and get cryptocurrency for doing them. My main claim to fame there was integrating the Earn experience into the consumer native iOS and Android mobile applications at Coinbase. Now I'm on the Pro Mobile team working on the Pro Mobile application. And you can follow me on Twitter, @htormey is my handle, if you want to hear me rant and rave about all things mobile and cryptocurrency. So what am I going to be talking about today? Well, I'm going to start off by giving you some background information about what Coinbase is and how the Pro Mobile application is different from our other mobile applications and what it does. And then I'm going to talk about how React Native helped us to ship this app really quickly. I'm going to touch on how it helped us scale the team. And then I'm going to talk about what was hard about building a real-time trading app like this. I'm going to talk about performance from a few different perspectives. And then I'm going to dig into interactive charts. And then I'm going to talk about something that you should all be familiar with after Simon's rant, which is the poor state of third-party React Native libraries. And I'm going to offer some opinions there myself. Okay, so before I go any further, hands up if you have ever used Coinbase before. Ooh, nice, nice. Keep making us money. That's awesome. Well, in case you haven't, Coinbase is a cryptocurrency exchange. And what that means is we provide a series of websites and apps that allow you to take your debit card, your credit card, or your cash and turn it into a crypto asset like Bitcoin or Ethereum or one of the other ones that are listed out there today. Up until a couple of months ago, we had one mobile application that allowed you to convert your cash into cryptocurrency. That was the Coinbase application. And the Coinbase application is a native iOS and Android application. We just released the new Pro mobile application. And you might be asking yourself, well, Harry, what is the difference between the Pro mobile application and the normal Coinbase mobile application? And I would say that it's targeted at more advanced users. So in the Coinbase mobile application, you open it up, you look at the price of Bitcoin, Ethereum, or whatever, and you say, I want some of that. You input it in US dollars or whatever, and you press the button, and that's the amount of Bitcoin that you get. You're placing what's known as a market order. The market determines the price that you're paying. The Pro mobile application, it's targeted at more sophisticated users. These are people who want to eyeball real-time information about a given market like Bitcoin or Ethereum and make a decision, place an order, to buy a quantity of that asset at a specific price and at a specific time. So to give you an example of one of the orders that you can place in the Pro mobile application that you can't place in the consumer mobile application, I am going to point to this screen that I have up here, and we're inputting a limit order. So a limit order is an order that specifies conditions for when to buy or sell an asset. So this screenshot was taken a while ago. The price of Bitcoin was over $9,000, and we want to say, hey, if this drops to 8,500, I want to buy a small amount of Bitcoin, but I only want this order to stay open for just one day. If this order is not executed by the exchange will cancel it for you and you'll get your money back. So that's the type of orders that people using the Pro mobile app want to do. So what's an example of real-time data, right? Well, an example of that you can see in the Pro mobile application, and this is from our web app, by the way, is an order book. So what is an order book? It's a sorted list of all the buys and sells on the exchange on that given market. In the center is the spread, which is the space between the lowest sell order and the highest buy order. Another way of visualizing market activity is with a depth chart. So this shows the supply and demand in the market at each price point, right? So you want to see basically the depth of buy orders and the depth of sell orders for a given asset like Bitcoin, Ethereum, or what have you. We also allow you to visualize market information with candle charts. Candle chart shows for a given period, in this particular example, a day, the high, low price, and the close and open price for a given crypto asset. If you go to the Pro mobile application and you switch this from days to minutes, it updates in real time. So every minute, a new candle will come into the view, and you can see by touching it and scrubbing up and down these values. Okay, so now you have an idea about, the difference between, the Pro Coinbase mobile app and the normal Coinbase mobile app, and you know what Coinbase is. How did React Native help us ship this app really quickly? Well, I think there's many ways that it helped us, but I'm going to focus on one or two areas where I think it had the most impact. And the first of those is in scaling the team. So what do I mean by scaling the team? Well, if you're trying to build any large-scale engineering project, you're likely going to face two major problems, especially in a hot job market like San Francisco. Number one is in hiring or recruiting new people to join your team. The second is in ramping up people on the technologies that you've decided to use to build your product and the code base that they're going to be working in. So as a general rule of thumb, hiring an engineer can take 90 days or even longer. Hiring an experienced native engineer is really hard. It's a really hot market for people with that skill set. Lucky for us. Ramping up a new engineer can take about 1 to 3 months, depending on your choice of technologies, right? So one of the selling points of React Native is that if you are a React front-end engineer, you know a lot of the things that you need to be successful in React Native. Unlike with, say, Flutter, where you have to learn maybe a new language that's very verbose, like such as Dart, right? And then, I'm not dissing Flutter or saying anything negative about that, but that is something that you have to factor in when you're bringing in new people in your hiring pipeline, like we have to do at Coinbase, right? Like, do we have to teach these people a new language? Do we have to learn together as a team? And what is the opportunity cost for doing something like that? So anyway, ramping up and hiring or recruiting, those are two critical things. So to illustrate this point, let's look at the history of the contributors to the Pro Mobile React Native project from the start of Q2 when we kicked this off to today after we've shipped it. So we kicked this project off at the beginning of Q2, and there was 3 engineers working on this project. Myself, Lucas, and Herm. Now, of these 3 engineers, only 2 of us had prior React Native experience. Herm was a native iOS engineer, and before coming to Coinbase, Herm had not written a line of React or React Native before. Fast forward to the end of the second quarter, and we had 6 engineers. And in particular, I want to call out 2 people in particular, Hannah and Clem. They are React front-end engineers. Now, Coinbase has different business units. There is a business unit that maintains the Coinbase consumer applications, and then there is the Pro Exchange business unit, right? The Pro Exchange, they already have a web application. They didn't have a mobile application. So what we did was we took engineers, really talented engineers like Hannah and Clem, over from the web team, and we cross-trained them to do React Native development. Now, Hannah and Clem had never done any native mobile or React Native development before, and they were able to ramp up super fast and be incredibly effective. So fast forward to the end of Q3 when we actually shipped the Pro Mobile application. Of the 7 engineers who are now working on the project, 4 of them had been cross-trained in React Native, and they all came from the web applications team. Today, we've had some success hiring. We're still hiring more. Q4, we have 10 engineers. Of those 10 engineers, the majority are people who have cross-trained from the Pro Web Applications team, and they now can go back and forth between mobile and web and do awesome stuff. So in summary, our choice of React Native allowed us to cross-train all of the Pro Applications team to be React Native developers. They were all familiar with TypeScript and React, and so they could ramp up and be effective, and we could supplement their abilities by teaching them about native stuff or React Native specific stuff. It allowed native and web engineers to work together to ship a high-quality product faster than they would have on their own. The majority of web developers on Pro can now contribute to 3 platforms instead of 1. That's a massive win for an organization at scale. Okay, so the next thing that React Native gave us is 1 code base, 2 platforms. So you might be wondering, okay, Harry, we read the press release. Where is the Android app? Well, if you look back at the slide, we were very short-staffed when we kind of kicked this off. And we made the decision, much like the React Native core team did, to ship iOS first. Because we looked at our data and we said, hey, the most important product to get out the door based on our current users is the iOS app. We're going to ship the Android as a fast follow. So the Android app, it's coming out pretty soon. It's all React Native, all the same code base, but it's not out yet. So what was hard about shipping a real-time trading application like this? I'm going to dig into the architecture of the app now. But before I do, I want to talk a little bit about project requirements, right? So on the screen behind me is the web version of the Pro Mobile application. We had to translate all of this real-time charts, all of this complex data into an itsy-bitsy tiny little screen for traders to use. That is a pretty big design requirement that we had to meet. But apart from that, this place is a native mobile shop. There's a lot of native engineers working on the consumer mobile applications. And so our product managers, designers, and engineers, they wanted to be sure that we could ship a high-quality app really quickly because we don't want to damage the brand of the company. So they set us some requirements. They were like, okay, we need to see 80% plus code reusability between Android and iOS. We hit that requirement. Our cold app boot times need to be under 3 seconds in iOS and under 6 seconds in Android. That was hit. We need to see 60 frames per second on those charts and all of the core flows in the application, gestures, everything has to feel really nice. And we need to see, if required, that you can do impressive animations and transitions. The good news is we hit all of those requirements. So what third-party libraries do we have to use? Because I think the point that Simon made about basically if you are coming new to React Native, you have a sea of choices, and a lot of them are terrible. So here's some of the ones that we used. We used React Native Keychain for our secure storage, Redux Sagas. Hooks had only just come out, and we're actually planning on migrating over to a new hooks-based data layer sometime next year. React Navigation, React Native Gesture Handler, React Native Reanimated, which we're going to talk about when we get to interactive charts, and React Native SVG to actually render a lot of these charts. And I'm going to go into that a little bit in just a couple of slides' time. So what was hard about building this application? Well, I'd say there's three big things: performance, interactive charts, and the quality of third-party libraries, right? And I think Simon has given you more than a little preview of that, and I totally agree with the point that he's making. So streaming data is hard. Streaming lots of data to power lots of widgets is very hard, right? So I think the screen that typifies this the most is the market details screen. So when you start up the Pro Mobile application and you log in after signing up or doing whatever, you are presented with a list of markets. You select one of them, and it'll bring you in and show you all of this real-time data about our market. So let's think about what's on this screen. We have a real-time price header that's showing you the current price of the asset that you're looking at. We have two real-time charts in this tab layer here, and a real-time order book, which also lives in there. We have trade history. We need to show all of your open orders. And oh yeah, if you tap this button here, a gesture-driven order form pops up on top of all of that. Wowzers, that's a lot of stuff that's being rendered all of the time. So you might be saying, okay, well, what does a performance issue look like from the point of view of a user? Well, you know, you might just have a really hot phone. You're like, damn, this React Native stuff is burning through my battery. Oof, that's not nice. Your interactions, like when you're flicking things, it might be really slow and laggy, and it's like, that's no fun. You might have delays transitioning between screens, and your animations might start stuttering. So, you know, one of the things that you can do when you're like looking at a screen like this to deal with these problems is just not render it, right? So, for example, like our trade entry point, let me go back here. This little thing that floats at the bottom of the screen with the red and green buttons. If we're not using the order form, if it's not visible, just don't mount it, don't display it. Like unmount or pause everything that's not immediately visible to the user. The other thing that we did was, for all of these tabs that are getting real-time updates from WebSockets and whatnot, we wrapped them in a higher order component, right? And we paused and put them in a loading state, right? So they're not getting all of those real-time updates that are coming in every few milliseconds from the exchanges saying, hey, Bitcoin has done this, these are all the orders that are happening there. We just pause all of that. But let's dig in a little bit further. Let's say, you know, you've done a bunch of these things, but you're still having a performance issue. You're like, damn, it sucks. What am I going to do? So the screen before the market details screen is the market selector, right? So this is what you see, right, when you log into the Pro Mobile app. So you're like, okay, I want to check out the price of Bitcoin, so I'm going to click on the Bitcoin chart. And it transitions from the market selector over to the market detail. But you notice something. It's taken a really long time. Why is that? Like my PM is complaining about it. What am I going to do? Well, you have a bunch of tools that are open to you, right? If you're a native iOS or Android developer, you have Xcode Android Studio. If you are a React front-end developer, you can also use your Chrome DevTools. React Native in the simulator and like in developer builds of the device, it has the React Native perf monitor. And you also have the simple console.time function, which you can wrap functions in to see exactly how long they're taking. So what do we do to debug this? Well, Steph, the engineer who was working on this, he fired up the Chrome DevTools and basically looked at the chart of everything that was happening when transitioning between the market selector and the market detail screen. And he noticed something. He's like, damn, you know, this order book, which is powering a lot of our charts and is, you know, being displayed in real time, it's taking a long time to actually build that and keep it update from the WebSocket, like our sorting function. There's something wrong with it. And so the issue that we were running into was that every time we were doing a comparison to, you know, sort and build this book, we were instantiating big number. Big number was a rather chunky, thing to represent big numbers. We're passing in a price, we're instantiating that, right? So this is rather a problem because it was taking quite a long time to go from one screen to another. So Steph and Lucas both took a swing at fixing this. And Steph was like, well, what if we didn't have to instantiate anything? What if we were able to just do a straight up string comparison on these really big number strings that we get back from the server? So he came up with basically a purely TypeScript-based solution to this. And then Lucas was like, well, there's this third-party native library number. Why don't I throw it in? So which do you think was faster? Well, it actually turned out that when we swapped out to Steph's string number comparator, it reduced the time to build the order book by an order of magnitude from 230 milliseconds to 22 milliseconds, right? The number, the native-based one, was a little bit more, was still really good. But again, this is just one example of some basic troubleshooting that you have to do if you run into performance problems with React Native. And don't feel that you have to go to native tools or write native code to do it. Often, if you're coming from a React background, your knowledge of the Chrome dev tools and simple things like console.time, they'll serve you really, really well. There is a picture of Steph at the Facebook campus, which I'm sure Simon remembers as well. He's going to be doing a talk on React and React Native performance, which will be really awesome because Steph is a specialist in that, at the next React Native San Francisco meetup. So did we have to write any native code to overcome any of the issues that we ran into with the Pro mobile application? No. Would a native app, if you were doing this in Swift or Kotlin, have run into these issues? Yeah. This could have happened even if you're doing a native application, because fundamentally you're processing just a lot of data, you're pumping a lot of stuff through the application. So we didn't have to write any native code. Native app probably would have run into these issues. So what's the thing that I'm going to talk about next? I am going to talk about interactive charts. So how do we build our interactive charts? Well, we use a library called React Native SVG, and basically these charts are a composite of lines and shapes on top of one another. We use D3. In version 4 of D3, they've extracted some of their models, so they're not coupled to the DOM. So we use D3 scale, D3 shape, and D3 format. So to give just one example, our candle component receives D3 scales through props. We pass them down, and that's how they calculate the scales and positions of the candles on the charts that you're seeing. Okay, so what is it about an interactive chart that makes it really hard? Well, in order to understand that, we have to dig into a little bit the architecture of React Native. So every single React Native application, it has at least 2 threads in it, a native thread and a JavaScript thread. And both of these threads, they're pretty fast. And in the JavaScript thread, your business logic, like how your UI is laid out and what happens when you tap something, or, the algorithm that you're using to kind of fade in or fade out something, all lives on that side. But the native thread is responsible for rendering, interfacing with the low-level operating system, basically all of that touches and stuff like that. These 2 threads, their memory is totally separate. So if you want to access memory in one thread from another, you have to serialize it and pass it across the bridge, much like if a client was doing a GET request to a server in order to query something that's in its database. So a consequence of this would be, if you are doing the naive approach, if you are implementing all of this logic in JavaScript, you could get into a case where a lot of traffic was being put on this bridge, right? So as you were scrubbing back and forth, it could end up serializing a lot of things, passing it back and forth across the bridge. And the JavaScript thread, which handles all of your other business logic, could get very slow. And your users would start to notice weird things like animations slowing down, things not being executed properly. So how do we solve this problem? Well, another approach that we might take would be a more declarative approach. So we would say, okay, instead of writing all of this purely in JavaScript, what if there was a way for me to tell the native driver, hey, when someone touches the screen and you do this and this and this, I want you to animate this widget by a certain amount, and when you're done with the animation, or when you've reached a certain point, I want you to call me back. I want you to call this JavaScript callback or TypeScript callback, and I am going to maybe do something else, like maybe update the prices that are being displayed over here and send you back some stuff. And the declarative API that we use to achieve this, along with a couple of other tricks like setting native props and stuff like that, is React Native Gesture Handler and its sister library, Reanimated. So would a native app have run into these issues? No. It's much easier to do interactive charts like this, I think, in a native application because you don't have this bridging problem. And I think it's worth mentioning that the React Native core team is working on some stuff that I think will make interactive charts easier. I think there's the asynchronous bridge and a few direct reference things that are kind of coming down the pipe, and I think it will get easier. But right now you have to rely on some third-party libraries that have APIs that maybe are not the most intuitive things in the world, and you are subject to perhaps some of the issues that Simon brought up, like maybe the library maintainers aren't quite as fast as React Native Core. So far, React Native Gesture Handler and Reanimated haven't suffered from these problems because they're maintained by a guy in Poland who is a former React Native core member and former Facebook employer. They're pretty awesome libraries. But again, it's something to think about. Which one of these things should you use? So a member of our team, Clem, one of the engineers that I mentioned early on in my talk, he gave a talk on this, which you can view, called Visualizing Interactive Data Using React Native. If you go back to my Twitter feed, I tweeted out this talk when Clem gave it. It's really worth watching, and hopefully Clem will give it again at another conference so you can all see it in person. Hannah Jin is going to be following me. Hannah works with me on the Pro Mobile team. Hannah's an amazing engineer. She's going to be talking about gesture-driven animations. Hannah did a lot of our bottom sheet flow in the Pro Mobile application. So if you downloaded that and you played around with the bottom sheet, you can thank Hannah for it. She's going to be talking about gesture-driven animations with React Native. So the point that I'm going to finish on, and I don't think I can really improve on Simon's kind of rant about this, is third-party libraries. So React Native is not really that old. I think it's a little bit over 4 years. Is that true? Yeah, it's about 4 years old. And a lot of the libraries that were built for React Native were originally built by web engineers, because the majority of the community that I meet out there are people who come from a React background who want to build a mobile application. And so the code quality and the maturity of these libraries can be often hit or miss, right? And so you might be saying, oh, Harry, you have all these engineers, why don't you roll your own? And the fact of the matter is the ratio of native engineers on our team to web engineers, it's pretty skewed. So right now, today, we don't have the resources to do this, but it's something that we want to do. We are hiring on the Pro Mobile team for both native, React Native, and people with a React web background. Talk to me after this talk if you're interested in helping take these native libraries to the next level or working on other awesome React Native project stuff. And that's the end of my talk. Hannah is going to be coming up and talking about gesture-driven animation in just a second. And thank you very much for listening to me rant about React Native. Introduce you. Oop. Sorry, folks, we're just loading it up. So the next person who's going to be talking tonight is my teammate, Hannah. Prior to coming to Coinbase, Hannah worked at Robinhood on their web team over there. Hannah really has a talent for, I think, amazing user interfaces, and she did a really great job with our gesture-driven animations in the Pro Mobile application. So please give a warm welcome to Hannah, who's going to be talking about React Native gesture-driven animations.
Thanks, Harry. All right, thank you all for coming out today. Hopefully I won't take you that much longer. It should be about 10 minutes. So my name is Hannah. I'm going to share with you my journey to here, to Coinbase. So I started out at Robinhood actually as a backend engineer out of college. And I thought I was going to be building out brokerage systems and clearing trades and settlements. But it turned out that I was really good at front end when I accidentally worked on a front end project to help power some of the brokerage business. And then, sorry, this clicker is. And then we needed to launch the web app at Robinhood, so I was asked to help out with that project, and I helped launch our web app in the US. And then I came to Coinbase about 7 months ago, and I worked on the Pro team, which is our advanced trader app. And here is where I started working on React Native. And just a few interests of mine, I'm very interested in fintech, UX design, and also education. And recently I picked up a new hobby or interest. I started cutting men's haircut and have one returning customer right now. All right, so I'm gonna break this talk into 3 parts. First, I'm going to just show you guys some common usage or really cool, actually, branding usage of gesture-driven animations. And then Harry talked a lot about the bottom sheet that we built for the Coinbase order form flow. So we're gonna dive into how to build a bottom sheet. And then we're gonna go into some advanced features of building an awesome bottom sheet, like adding snap points and make the animation really fluid. So the first one I'm gonna show is from iOS, but this actually exists for a lot of mail apps as well. It's when you slide, you can delete and trigger more actions on an item. And the next one comes from Robinhood. For those of you who have used Robinhood, this is actually a really beloved feature. It makes the app super fun when you're submitting an order. It uses this swipe up gesture to send the order to backend rather than you tap a button. And the next one comes from Tinder. I'm sure you all have heard of the swipe life, the swipe gesture. It really made Tinder's name and is a huge part of their brand. And the last one is actually my favorite use case for bottom sheet. It's from Apple Maps. It allows you to view the map while you're doing your searches and go back and forth really smoothly. So why should you care about gesture-driven animation? Or like, it seems very complicated to build, but what does it give you with all that hard work? So the first thing is it's extremely intuitive to our users. All the gesture-driven animation mimic what we expect from the real world, following all the physics principles. The really popular one is spring animation. And on mobile, we have much less real estate compared to web, compared to tablets. So with the smaller real estate, we have to think of creative ways to allow user to complete a lot of actions that does not clutter up the UI, the screen real estate. And it's super fun. It adds a more game-like feeling to the apps, and it makes the app super addictive in the case of like Tinder or those social apps. And the last thing, it can become part of the branding. In the case for both the dating apps and also Robinhood, it became a strong part of their branding. So this is the bottom sheet that we built for Coinbase, and we are using it for the order flow. And as Harry mentioned before, we really want to have that context of the market data while users are placing an order. And it allows the user to sort of multitask, so they can interact with the chart while they're typing up their order details. And if anything changes, they can immediately change the order they want to place. And there's a lot going on the screen, so it's really hard for us to fit everything as it is. And this gives us a really easy and nice way to introduce one more thing to the screen without making it feel really clunky. All right, now we come to the technical part. We're gonna build the bottom sheet together. To really simplify this, I sort of boiled down into the gesture handling and the animation part. So can I get a show of hands, how many people here have used the animated API from React Native? Wow, that's better than I expected. That's really good. All right. So Usually when I think about building a feature, I look at what the specs are, so what we expect to happen, and what are the technical solutions. And as I mentioned before, there's the gesture part and then there's the animation part, and I like to think about them separately. And for the rest of the talk, we'll think about them separately to keep things simple. So we want to track the finger movement, and to do that, we need some sort of sensor from the native hardware. So we use a pan gesture handler to get that data from the events. And that's all we need for gesture, because the gesture is not the part that makes all the rest of it happen. It's just a data input. It's a demand from the user. And then we want to respond to the gesture command, which would then run a spring animation. So spring sort of follows this law of inertia. So based on how fast you're moving, how much distance your finger moved, we decide how fast and how much distance the bottom sheet should travel. And the last thing is what really makes bottom sheet very special is this anchoring. So we want to have snap points in a bottom sheet. If there's only one snap point, that's really not a bottom sheet, it's just an overlay. So we need to have at least 2 snap points to make a bottom sheet. And in more advanced bottom sheet, in our case, our snap points are actually dynamic. So first step, we're just going to create an overlay, and that's what we call bottom sheet. And we're going to use absolute position. Super simple, nothing really special going on here. And then we want to add the pan gesture handler around it so that we can start capturing some of that gesture data. And for this, I chose to use React Native gesture handler. It's not a requirement. React Native has a pan responder if you're more comfortable with that API. So we just wrapped around the pan gesture handler around our view. You guys still following? Good. All right, so we have our gesture handler, but it's really like not doing anything right now. So we wanted to start capturing the native event. So if you come from a web background, it's very common to have event handlers. So this is the same concept. We want to capture this event, and we are in particular interested in 2 values that comes from this event. The first one is translation Y, and the second one is velocity Y. So as I mentioned before, in order to deduce this inertia, this animation, we want to know how much the finger has traveled. And since we're making a bottom sheet, we're interested in the Y direction. So translation Y gives us the delta that the finger has moved for this particular gesture event that we're dealing with. You might have a ton of gesture events as user moves the finger around the screen. And also the velocity. So we captured those, we put it on a component instance. We're good to go. And I want you to pay attention to this line. It says use native driver. So as Harry alluded to this before, when we are working with React Native, there's the React Native thread, and then there's the native thread, the UI thread. So when we're doing animation, this becomes a particular acute problem when you're traveling across the bridge a lot, because we want that 60 frame per second experience. So we don't want to have to use a very imperative API where every time something happens, we come back to the JS thread and we're like, oh, do something else. So using native driver allows us to pass the entire logic of how the animation should work, so like the physics. And we pass that data ahead of time to the native side. And after that, all the animation is going to run on the UI thread. So this is just a definition of what use native driver does. And we put all that code together. This is what it looks like. Any questions so far? Okay. And next thing, so up till this point, we haven't done any animation yet. We've set ourselves up to handle the animation. So from now on, we're going to transition into the animation part. So first, we want to know how much to move our actual bottom sheet. And the value we're going to use is called this translate y. And to figure out what the translate y should be, we have all this delta that we gathered from the gesture events. So we want to keep updating the accumulated movement from every single gesture. And then we add this style to our bottom sheet. So now, if you can visualize for me, we have a bottom sheet that's actually just moving however much the finger has moved. There's no snapping, there's no like inertia and following the velocity of the finger. But at least we're responding to the gesture event. So this is all the code pretty much to do that. So now we're going to add the snap points. So just a recap of what that looks like. So as we swipe down, it snaps to a half screen. So that's like one of our snap points that we set for this particular step. So to do that, we use a spring animation. So the code here is kind of what it looks like if we didn't use any declarative API. So this is the code that will look like if we're just writing only React Native. We don't introduce any React Native reanimated. So as you can see, we have to imperatively trigger the animation on the handle gesture state change. And then we check if the gesture has ended, then we start this spring animation. And here is how we calculate the snap points. We have to create a loop, and this loop will run every time we want to handle a gesture state change. And that's a lot of calculation. So to avoid that, we chose to use React Native reanimated. And what that allows us to do is now we can create nodes that have side effects. And the side effects are those timers that we kick off to start our spring animation. So here is the same code, but written using React Native reanimated. They have a domain-specific language, so at first it might seem a little strange, but all it's doing is the condition is checking a condition. So the first argument there is checking if the gesture state has reached end state, and then we do, if it has, then we want to run our spring animation, and the output of that spring animation will be our translate y, which is how much we want to move the bottom sheet. And one thing to point out there, which might be a little strange, is when you move down, the number actually increases. And then when you move up, the number actually decreases. So if you want to be at the top of the screen, that's like a 0. So how do we find snap points if we're using React reanimated? As we saw, if we're using the React Native API, we'll have to recalculate that value every single time. So in order to do that, we use node again, so the animated nodes. And if we have 2 snap points, then it's pretty straightforward. We find the middle point, and we compare our gesture final translation y if that is above the middle point or below the middle point. So above the middle point would be less than, and below the middle point will be greater than. And it gets really tricky when we want to do arbitrary number of snap points, especially with this API. But a really good way to think about this is actually recursion here that we want to achieve. But instead of thinking in the terms of a recursion, I find it really helpful to keep this logic of if statement branches. So what we're doing here is we're checking if the final translation y, which takes into account the velocity and how much the finger has moved, the translation y, or delta y we call it in our component. and then we compare it against the first midpoint. So the midpoint between the first snap point and the second snap point. So if it's above the first midpoint, then we choose our first snap point, we're good. If it is not, then we start checking the rest of the snap points and then repeat this logic again and again and again. So to condense all that, we have something that looks a little magical like this. But all it's doing is just what we saw earlier, just in a recursive way that can be extended to arbitrary numbers. So that's all just to create a basic bottom sheet that can snap and move based on the finger and the physics. There's a lot more to a bottom sheet that you can add and you can play around with in your products to make it better. So a few of them that we did for our bottom sheet is we need to programmatically change the height. So when you click that buy button, we want to trigger the sheet up. And then we also have an X button that allows you to close it without using gesture. But obviously you can close it with gesture. And we have a few steps in the order form, and they all happen in the same bottom sheet. So we want to change the height of the bottom sheet, and as the height changes, we also want to change the snap points. And also, if you remember in the video, we can actually pull our bottom sheet up, but it's actually a very strange experience if we pull it up way beyond the top of the screen. So we want to limit how much of that user can do. So to do that, we can add animation to calculate like, oh, we're actually moving beyond the initial position of our bottom sheet. So we want to limit how much that can move. And last but not least, if you have a lot of data that needs to live in the bottom sheet, in the case of Apple Maps, where you can scroll the data, we want a smooth transition of the gestures between the pan and the scroll. Like when you reach the top of the scroll view, we want to naturally transition to pan so you can pull the bottom sheet down. And I want to leave you all with this one food for thought. What gesture-driven animation could you bring to your product? Thank you.
Hey. Well, that was our last speaker for the evening. And thank you very much, Hannah. That was an amazing presentation. Really good job. If you would like to work with me, Hannah, or any of the other people building awesome stuff in React Native, we have a ton of features that we couldn't get done in 6 months. We have like so much awesome stuff to do, including sharing business logic with the web, doing stuff with native code, doing stuff with TypeScript, the works. Come talk to me or come talk to Hannah or even Yulia, who's actually doing work over there at the moment. Yulia's on our team as well. Yulia's awesome. We'll tell you about like Coinbase and all the cool stuff that's going on here. But feel free also to just have a drink and mingle and talk about React Native, because that's why we're all here. And thank you very much for coming out this evening. And that's it.